Welcome, y'all, back to some more geometry. Today, we're starting a new chapter. We're talking about classifying triangles. This is goals. It's because for some reason, this is being weird. There we go. Triangles. Triangles. All right, so let's start with just defining triangles. Triangles, again, are a figure formed by three segments. Now, remember, segments has a stop point and end point. So just segments are just endpoint. Ooh, why is, oh, because it's color white. That's funny. Endpoint to endpoint, right? So if you put three of them together, not in a line, then you get a triangle. There's one, there's another one, and there's the third one. Triangle. Now, the points of a triangle, there go vertex. They're the intersection of the segments right there, the vertex. And now the segments themselves right here are called the sides of a triangle. Sides of the triangle. There's three sides. Now, triangle can be classified by two different ways, by their sides and by their angles. Let's start out with their angles. So as far as angles goes, it's all dependent on really what all the angles have in common. So right here, this is what we call an acute triangle. It's an acute triangle because all the angles are acute. Remember, acute means less than what, y'all? 90 degrees. Yeah, every single angle is less than 90 degrees. They don't have to be the same. They don't have to be congruent to each other, but they're all less than 90 degrees. An obtuse triangle is a triangle that has one angle that is obtuse, just one angle. Now remember, obtuse means greater. Ooh, spelled greater wrong. My gosh. Greater than 90 degrees, but less than 180. A right triangle has one right angle. Right angle means it equals 90 degrees. And the equal angular triangle it's a triangle where all angles are the same. Now here's the thing. Here's the fun fact. What is the measurement of each of these angles individually? Now again, in a triangle, all three angles equal 180 degrees. And if they're all the same, what are they? Tick, 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 tick. Yep, you're right. It is 60 degrees. They're 60 degrees because 60 plus 60 plus 60 is 180. Let's talk about the sides now. The sides. So a sides we start with the first one. It's called a scalene triangle. Scalene means every single side is different. They're not related to each other. So you'll see these marks right here, single, a double, and a triple. That means all three of them are their own unique mark. They have nothing in common. An isosceles triangle, isosceles has at least two of them that are the same. So for example, these two side ones, they intend to be those sides, will be the same to each other, and then the third one will be the different one. An equilateral, now it's a equilateral triangle, all three sides are congruent. Now, equilateral is also an isosceles triangle because isosceles by definition is at least two. So it can be more than two. For example, three. But an isosceles is not equilateral because equilateral is all sides the same. So as far as your homework's going to go, you're going to be giving some information something like this. Like, hey, classify the triangles. And we're going to classify them by angles, by their angles, and by their sides. So by their angles and by the sides. So look at this first one, triangle ABC. By their angle, what kind of triangle is this? Well, let's start with the sides. Actually, the side's easier. Since this side, and this side, all three sides are the same, that's a equilateral. Yeah, equilateral. And by their angle, since they're equilateral, all equilateral triangles are also equiangular. Equiangular. That looks horrible, but it's equiangular. So the next one, ABC. ABC. This big triangle right here, ABC. Yeah. So by their angles, look at their angles. So there's this, I'm going to put this in blue. There's this triangle right here, this angle right here, and then this angle right here. All three of them are different, okay? But let's look at them. Are they all less than 90 degrees? I'm going to say no. This angle B actually looks greater than 90 degrees. It looks a little bit bigger. So by that definition, it's an obtuse triangle. Now, by their sides, all three sides, this side, this side, and of course this side, they're all different. So that's a scalene triangle. All right, let's look at triangle EDC. EDC right here. So by their angles, it has a right angle, EDC, triangle EDC. So it is a right triangle. And by their sides, all three sides are different from each other right here. So it's also a scalene triangle. And then look at BDC. So BDC is this triangle right here. And put this in this lime green. Here, 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 and here. So this triangle right here. So based off the angle, you have this angle, and this angle right here. So based off the angle, because this is the biggest angle right here, and it's over 90 degrees, it's an obtuse triangle. Now based off these sides, you see how these have the same mark, this right here and this right here? These two sides are congruent to each other. That is our isosceles triangle right there. All right, y'all? That's all you'll be doing for 4.1. Y'all have a great day. If you have any questions, let me know. Bye.